Hello, my name is David Reamer, and I'm from Luna Innovations. In response to an increased occurrence of physiological episodes in fast jet aircrew, we're developing a non-invasive wearable monitor to detect real-time human hydration levels. We do this using the same innovative processes that have led to Luna technologies being implemented in such advanced systems as the F-35 and the Orion spacecraft. This technology is not only novel, it's also expandable. And if you have a need for such an important measurement as hydration, we want to work with you and we want to hear from you. Luna was founded in 1990 and is headquartered in Roanoke, Virginia. Since our founding, we've grown to approximately 270 employees. Luna has equipment selected for or actively deployed in multiple infrastructure and aerospace products, including fiber optic sensors in the 55-kilometer-long Zhuhai-Macau tunnel bridge system, and corrosion monitoring and sensing products in systems such as the Orion spacecraft crew module and the CH-53K helicopter. Luna is split into two major divisions. The Lightwave division primarily works in the development of fiber optic sensing methods and equipment. Luna Labs, where this project is based, is our applied research arm. Luna Labs has over 65 engineers, of whom about half hold advanced degrees. We're focused in three primary subgroups, including material science, embedded electronic systems, and biotechnology. This unique arrangement allows us to tackle and provide robust solutions to a massive range of engineering challenges. So what exactly is the goal of this project? It's to develop a real-time, non-invasive hydration monitor for Navy fast jet aircrew use. We call this the Wearable Aircrew Hydration Tracking and Extended Recording, or WAHTER system. The Navy has observed that dehydration plays a role in the occurrence of physiological episodes. In response to this, we're developing a novel system that uses a miniaturized electronics package and a non-invasive disposable sensor placed on the arm to record real-time changes in a pilot's hydration level. Our initial transition targets within the Navy are PMA 202 aircrew systems and PMA 265, the FA-18 and EA-18G program office. We believe these offices stand to benefit the most from the immediate application of this technology. WAHTER is specifically intended for use in the environmental swings present in the fast jet flight environment and is operable entirely independent of any aircraft systems. Additionally, WAHTER has been designed from the outset to securely communicate with other physiological monitoring systems, such as Athena GTX's HMAPs. This feature will aid in simplified user interfacing and data display. So why exactly is this device needed? Well, it's in response to an uptick in the number of physiologic episodes experienced by fast jet aircrew. A physiologic episode is an event in which the mental or physical capability of the aircrew is compromised by some external factor. The result of these episodes is not only a safety risk to the aircrew, but also a drop in efficiency, mission readiness, and lethality. If an aircrew has to abort a mission early due to a physiologic episode, that's a huge detriment to the overall agenda of the unit. Significant resources have been expended in identifying and ameliorating causes of these episodes, and dehydration has been identified as a significant cause. Why is that? Well, mission durations keep increasing, and inadequate or inconvenient relievement, especially for female pilots, may prompt unintentional dehydration. This system can help aircrew stay on top of their hydration levels to ensure optimum performance. It's important to remember that aircrew already wear a lot of equipment, so another system needs to be small and have crew investment. So what's needed here is a non-invasive, wearable monitor that can withstand the fast jet naval aviation environment while accurately reporting systemic hydration. In this case, investment's the easy part. This technology is not yet commercially available, aka it's really cool. And as we all know, fighter pilots love being cool. Beyond just the Navy, even beyond the Department of Defense, there's a significant demand for this type of technology. Fields such as professional athletics, healthcare, construction and heavy industry, and personal health monitoring all have widespread demand for this type of technology. WAHTER represents a leap in physiologic monitoring capabilities. To use it, a simple Band-Aid style sensor is applied to the inner forearm. For fast jet aircrew, the left arm is likely preferable due to its relatively static positioning and throttle operation. The sensor is connected to a small electronics box also on the arm. The system then autonomously measures various electrical characteristics from the skin. The next step is data processing through analytical and machine learning models, which decode hydration-dependent variables from that electrical signal. This process is repeated at regular intervals to create a current and past hydration history for the wearer. This measurement is entirely safe and does not cause any feeling or discomfort to the wearer. Data output can be displayed on the device itself, or as I previously mentioned, WAHTER can securely and wirelessly communicate with other physiologic monitoring systems and transmit and receive data from those systems. WAHTER is also designed for uninterrupted use over the course of a complete mission, so battery life is projected to be at least 8 hours, with the potential for significantly longer unrecharged operation. So where is WAHTER now? We're currently in a Phase 2 SBIR contract, having just completed the first year of performance. Early in the Phase 1 project, we demonstrated technical feasibility of this hydration monitoring concept using early sensors, a synthetic skin analog, and first-generation hardware. Later, in the Phase 1 option period, we validated conceptual functionality on porcine and surgically excised human skin. These tests confirmed that changes in skin hydration were quantifiable with the WAHTER system. We're currently in the Phase 2 base period, where significant work has been performed on refinement of the operational theory, as well as development of next-generation hardware. In fact, we've just completed the production of next-generation, entirely self-contained hardware boards that are only 1 inch by 2 inches in size. We have also produced additively manufactured device casings, which can be rapidly updated as the system footprint is refined. Additionally, we have acquired clearance from both our Regulatory Oversight Board and from the Navy to perform in-house human trials on volunteers. This will afford us the opportunity to significantly refine our processing algorithms to ensure accuracy in hydration measurement. After this, the step is an additional human trial with our partners at the University of Virginia Exercise Physiology Lab, where our sensors will be placed on athletes undergoing strenuous exercise-induced dehydration trials. This study will provide significant insight into WAHTER functionality in the real-world environment and will allow us to keep refining our data processing algorithms. A final human trial with participants wearing relevant flight gear and experiencing flight-relevant environmental changes will provide confirmation of WAHTER operation in the fast jet flight environment. We expect that this trial will contribute to the identified pre-deployment testing, and Luna will work with identified transition partners to then move WAHTER into early-stage deployment trials. Now, if I haven't yet convinced you that WAHTER will provide you as a Navy customer with significant benefits and improvements, let me lay out a few more scenarios for you. First and simplest, there's just no commercially available way to monitor hydration levels in aircrew, or any crew, sailor, or soldier for that matter. I think it's pretty apparent that the incidence of heat exhaustion could be reduced if crew standing on an 140-degree aircraft carrier deck in the Middle East had a way to track their hydration in real time. Next, steering away from the intrinsic health benefits of knowing your hydration in real time, let's look at efficiency. Physiologic episodes are not just a risk to the health and safety of the aircrew, they also cause significant inefficiencies, reduce mission readiness, and on multiple occasions have resulted in damage to or loss of aircraft. While the cause of physiologic episodes is a multifaceted problem, our simple, unobtrusive, and low-cost solution can help give pilots one more piece of information to potentially avoid such an episode. That leads into my final point. The Navy has spent several years, and at last count almost $100 million, on understanding the root causes of physiologic episodes. And good progress has been made, with massive reductions in the occurrence in the T-45 fleet and a good reduction in the FA-18 and EA-18 fleet. Advances such as the slam stick pressure recording device have helped to quantify the environmental exposures that pilots face in the fast jet cockpit. However, human physiology is extremely complex, and our technology represents a breakthrough in the capability for measuring a highly important human health metric. This is concurrent with the Holistic Modular Aircrew Physiological Monitoring System, or HMAPS, and WAHTER can communicate with HMAPS to give a fuller picture of how the pilot is responding to the environmental stressors and further understand how to reduce physiologic episodes. Now, cap this all with the fact that Luna has been developing miniaturized, hardened devices for use on military aircraft for more than a decade, and you can see that what we're offering is a tool that will become a high-value asset in your arsenal. Let's talk a bit now about how we're validating WAHTER functionality. As I mentioned previously, early validation tests with synthetic skin analogs, as well as tests on waste skin samples removed during surgeries, have demonstrated technical feasibility. While this testing is invaluable for early validation, to move the testing forward, we need to do trials on humans. In that scope, we have received Institutional Research Board clearance to perform in-house testing on volunteers. Additionally, in the interim between the PAO approval of this presentation and now, the Navy has finalized review of our human testing plans and has granted us testing approval. The first test will focus on collecting data from volunteers across a range of hydrations and using this data to give our machine learning models a training set or effectively to teach them how to identify dehydration. This trial will begin imminently, pending activation of the next stage of funding. We have also begun design work with our partners at the University of Virginia Exercise Physiology Lab to create a study where subjects will undergo exercise-induced dehydration over the course of several hours while wearing the WAHTER system. This study will commence within the next year and will allow us to refine our algorithms even further and perform precision accounting for variables such as body type, gender, age, height, weight, and other similar biometric variables. We will then move to environmentally relevant testing with partners at KBR. Subjects will wear appropriate flight gear and will wear the WAHTER sensor while experiencing a range of environmental changes relevant to the fast jet flight environment. This test is important to validating functionality in the fast jet environment, and while initial test plans have been evaluated by the Navy, further planning will be done in conjunction with them to ensure that this test applies towards fulfilling pre-deployment evaluation criteria. Beyond the Phase 2, we want to move to initial deployment evaluation with a test squadron such as VX-23. This should go in tandem with achievement of low-rate initial production. So what do we need to move forward? Well, to get beyond the Phase 2, we need transition advocates. And while we think that PMA 202 and PMA 265 will be great offices since our offering is so closely aligned with their needs, they're not the only ones we want to hear from. As you can see from a small sampling of possibilities shown on the lower right-hand corner of the slide, the results that WAHTER can deliver are widely applicable to a range of other needs. So please stop by our virtual booth and talk with us. We want to hear what your needs are, and we want to partner with you. Beyond just the Department of Defense, there's a wide range of customers who are interested in hydration monitoring technology. You may have just heard of Gatorade's collaboration with a university spinoff to create a single-use sweat analysis patch. While this solution cannot directly measure hydration, it shows that there is a huge market demand for physiological monitoring products. You need to look no further than the Fitbit revolution to see this. Take a look at that statistic at the bottom of the slide. The market for wearable technology is expected to reach almost $57 billion within the next 4 years. This technology is in demand. To help quantify this demand, in the Phase 2, we're enlisting the services of Foresight Market Research, a well-established market survey firm. This survey will help us identify non-military customers who want to partner with us to help get WAHTER technology into commercial use. We have no doubt that the demand will be high. Additionally, we will contract with another company, NAMSA, to perform a regulatory assessment. This will help us identify any regulatory requirements in the commercial sphere to which we need to conform, thus helping us avoid any pitfalls in passing such requirements during our advanced technology development process. Luna performs these type of assessments on products that are being positioned for military and commercial transition to help ensure a successful device partnership and transition process. This slide shows a rough workflow for how we envision a transition process may go with a Navy partner. We're in the blue section right now. We're working to build relationships with you, a potential transition partner, while we're advancing our technology and validating it with various human studies. We will then need guidance from our partners to help identify things like pre-deployment testing requirements, as well as serving as an advocate for long-range planning for future WAHTER acquisition. What do you get from this? Massive benefits. As we discussed earlier, our transition partners stand to achieve first-in-kind physiological data, whether it be from aircrew or other sailors or soldiers. Imagine the capabilities that would give you. After this stage, we will work with our partners to scale up production and get WAHTER deployed into fleet use. At this stage, we would begin expansion into the commercial sphere as well. So in light of all of this, come talk to us. Tell us about what you need, or tell us ideas for who you know has a problem that we can help solve. Just navigate over to the virtual booth tab on the conference webpage and search for Luna Innovations. We have several folks available to talk, and we would love to connect with you. Other contact information is shown at the bottom of the slide. And I want to thank you for your attention.